Okay, so good evening, everyone. Welcome to the seventh live session for the course Concrete Technology offered by NPTEL. I am Arshit Agrawal, a PMRF PhD scholar from the Department of Civil Engineering, IIT Bombay, and I will be conducting weekly live session for this course for the entire course duration. So first of all, for those who have joined the session for the first time, what are these doubt clearing and interactive session all about? So these are weekly interactive sessions that are held every Tuesday from 6 p.m. to 8 p.m. till the course runs. And during the session, we interact either by answering to the questions that I will ask in the chat box, by posting your questions in the chat box, or by raising hand and muting and asking your queries. Apart from the class, you can use the discussion forum of the course for clearing your doubts, and attending this session regularly will help you to answer the graded assignments easily and will help you to further understand complex topics holistically. So, in today's session, we'll first revisit the last live session that was for week 6 content, just a quick recap, and then we'll go through the things covered in the week 7 content. The week 7 content that we'll discuss today, first, we will address the leftover part from week 6. That was batching and mixing of concrete. Then we'll talk about post mixing operations on concrete, which is divided into following subsections for today's discussion. First, we'll discuss rapid mix concrete, then transportation of concrete, workability of fresh concrete, different types of pumping system, compaction, underwater concreting, and curing of concrete. In between, we'll have some objective questions, like around 20 to 22 questions in total. We'll see that will challenge your understanding to the concept. And finally, we'll conclude the discussion and I will try to address any further queries post discussion. So, last week we concluded the week 6 content of the course where we continued the discussion on mixture design of concrete. We first solved a numerical based on DOE method of mixture design, and then we looked into ACI 211 method of mixture design, where we went through different mixture design steps starting from target mean strength calculation up till moisture correction. We solved a numerical also to understand the application of this ACI method. Then we saw a comparison between IES, ACI, and DOE method. So we saw that IES ACI method is more practical, DOE method is more strength oriented, and IES method lies between the two in terms of proportioning of components. Then we talked about advanced form of commixture design, which that is based on packing density, particle packing, and rheology of concrete. Such mixture design is typically used when we want to prepare a high performance concrete, which we can't prepare if we just follow conventional standards. Now, first step in optimizing particle packing, for which there are two theories: discrete approach and continuous approach. Using packing density, using these theory, packing density is optimized and void percent is minimized. Once packing is maximized, we need to take just enough space to make concrete is workable with desired strength, and the flowability part is controlled by the rheology. Okay, so to understand different key terms in rheology, we need to understand yield strength, plastic viscosity, and thixotropy. We talked about Newtonium and Bingham plastic fluid state. The first one applies for self-compacting concrete, and the second one applies for a conventional concrete. And finally, we saw how the concept of rheology parameters gets applied to concrete component in governing flow state. Like if my flow is viscous, what will happen? If flow is wet, what is will happen? And if my mix is stiff, what will happen? And how different components in my concrete mix can affect different rheological parameters. So now, before moving ahead, I will address three doubts from the last session based on assignment 6 first. So this was the question of mixture design based on ACI method that was there in the assignment. So the question says desired 28-day cylindrical compressive strength of concrete is 35 MPa with no air entrainment is to be used. The cement used is OPC and fineness modulus of sand is 2.6. Specific gravity of fine coarse and cement are 2.6, 2.7, 2.6, and 3.15. Density of water is given. Dry rotted bulk density we know. Maximum aggregate size is given, and the desired slump is given. And we have been given the minimum cement content and maximum allowable W by C ratio for durability purpose also. Standard deviation of the whole set is also given to us. So based on this given data, there were different questions that were framed in the assignment. And the first question in which the doubt was the determination of free water mix. Okay, so someone asked in the lives in the last session that there are multiple tables and like which table was supposed to be used. So if you see the second table that I have shown in this slide, it is the table that I have taught in the last session, and this last table that was there in the presentation that was uploaded on NPTEL, these both are the same. Okay, but for solving this question, the value in which the correct answer was mentioned, the range of value in which the correct answer was mentioned, for that they used this table that was there earlier in the discussion on NPTEL site. So you can see you have been given all the values. We have 19 aggregate and 80 slump. So 80 slump will lie in this range. So the correct answer will be 205 kg per meter cube. So that is how you will get the answer. However, the correct table or more updated table is this one. So you should like remember this table for like further answering. Okay.
Sir, but the question was, I think it is 25 not 19 sir.
No, no, it is 19 Is it 25 or 19?
It is 25, sir.
So if it is 25, then the answer will be 193. The
Yes, sir.
assignment copy that I have, it has written 19 So that's why I pasted that question here.
No, sir, it is 25 and the right answer was 193.
So
Okay.
they have used the old table. That's why the answer is coming out to be 190. If you will use the updated table, you will say answer will be 195.
So maximum size of course aggregate given it as 25
So
not 19.
so that's for that the answer will be 193.
195. Oh, yes, sir.
Okay,
Okay, fine,
the
sir.
question that I had na, it was showing 19 so that's why I told 205. Okay, this is a very simple question. You just need to remember this table and you will get whatever answer you want. Okay, so that confusion is clear. This table is different. This table is different. So this table, I guess it was shown during a numerical at the end, and this table was shown when the professor was discussing the theory part. So this might be an old table. That's why the confusion was created. Now the next question was we have now we have been given in the question that 20-day cylindrical compressive strength was 35 MPa. There was a confusion in three formulas and like which one to use. So this table, this first table that you can see, it applies to when we don't know the S value. Okay, when we don't know the standard deviation value, then we need to use this table. Okay. However, if we know the standard deviation value, then we need to use these two equations. Okay. So this is the equation that I taught to you in during the session. How we calculate the target mean strength if we are given the mean ca- characteristic strength. Okay. But there are two equations. So like these two equations, from both the question equations, we need to calculate the target mean strength and we need to take the maximum of two. Okay, so if we try to solve that question here, how which what will be the answer? Okay, so my target mean strength I am representing by TMS, so it will be maximum of 35 plus 3.14 times standard deviation 4, which is given in the question to us, or it will be 35 plus 2.33 times 4 minus 3.5. Okay, so if you will calculate this, it will come out to be TMS is equal to maximum of 40.36 and 40.82. So maximum value is 40.82. So this will be the correct answer for this question. Okay. So
Now,
don't get
sir, no,
uh,
sir. In the assignment again, there were two standard deviations which were given. Firstly,
okay.
and secondly, the first step what was taught was to convert this cylindrical compressive strength to compressive. So that means 35 should be divided by zero point 0.8 first.
No, no, like the assignment question that I have, it has the correct answer mentioned in this
That's
range.
what, sir. We are getting negative marks for this only because the in the assignment. So if you open the SWAYAM portal and see the question, sir,
Hmm.
we request that you to solve that question rather than this one, sir, because there were two standard deviations given in that.
Okay, that standard deviation 2 would be like 15 set standard
Yes,
deviation
sir.
it was.
15 samples
So
to.
that I will tell you how to solve. That is the third part
But
that
sir,
I will
in
be discussing today.
But sir, the first thing is that cylindrical compressive strength. The thing which has been given is the cylindrical compressive strength.
Hmm.
So that needs to be converted to cubical compressive strength. So that has to be divided by 35 has to be
You
divided
share
first by
me the
point 0.8.
question in the chat box, na. Let me solve it one and check what the value is coming, and then I will tell you.
Okay, sir. I'll
Sir,
copy that and
actually,
send it to you.
sir, just a second. Sir, actually, we have two standard deviation, right? So S1 and S2. So in the lecture, sir has explained that we have to
See, this is
convert it
the
that
huh,
into under root of that S1 square plus S2 square. We will
huh,
get the one standard deviation value.
that is what
So
I am
again, you have
showing
to
here
put,
in this slide.
yeah. So
So,
actual, we will get the answer is 35.82 megapascal. That is the
hmm.
answer actually.
See, this is
So
how
you,
that thing came. Someone asked me like why we are taking under root of s2 plus s2 square,
okay,
but that
okay,
is
okay,
just an approximation that we take. Okay, it is not
okay,
under root of s1 square plus s2 square. It is under root of s1 square plus s2 square upon 2. Okay, root
okay.
mean square. So you need to take mean of squares and under root of
Hmm,
that. Okay, so if you have two standard deviations, suppose you have two sets.
hmm,
N1 has
hmm,
15 values, N2 has
hmm.
15 values, and you know a standard deviation of both the set. Okay,
Hmm.
and if you know mean of both the set, then the combined
Hmm.
standard deviation is given by this equation. This is the correct method.
Hmm.
However, generally this x1 and x2, the mean of both the set will be very close to each other. So generally what is done, it is assumed that we can take a root mean square also as a shortcut.
Okay.
So
Okay.
that's
Okay.
why Professor
But right, right answer is sir 35.82 is the right answer
So
actually.
you just share me that question, okay? Because the assignment that I had, na, it has this question, so I was not able to do the solve the same question like that you have, but we will solve that. Okay, that is easy. So you just need to follow this step for that question. Take a root mean square, so it is like under root of s1 square plus s2 square upon 2. Okay, that will give you the standard deviation, and then you need to use these two formulas. Okay.
But sir, when we go for that mean, finding out the mean compressive strength,
Yeah.
at that time, what professor had told that the first we need to convert that into cubical strength and then compare with the table what you have given on the top, sir.
See, in this question that you have attached, this is the question that is there in the chat box. Is this the same question?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, so here it is mentioned 25. Okay, 25 mm it is mentioned. Okay, in my case it was 19 mm mentioned. And attach the second part also.
This is the only one question, sir.
Okay, estimate the mean cylindrical strength. Okay, that you can do na easily. So since in the question it is given to you directly that it is the uh, uh, 20-day cylindrical compressive strength is given na, so you can directly use
Um,
this formula. You don't need to convert into cube and then
uh,
again into cylinder. You need to directly
ye-
use this formula.
yes, sir. Exact. Because sir, actually, whatever the table given in ACI code, no, it is for the cylindrical
It is
strength
for
only.
in the ACI code it
Cylindrical
is
only.
mentioned for cylindrical, so you don't need to convert
Cylindrical.
this thing into cube.
Converted in. Yes,
Okay.
sir. Exactly. Right.
Directly
Right.
you have FC value that is given to you in the question, whatever it is given, 35, 40, whatever is given. Standard deviation you need to calculate. If there is two standard deviation given, you need to take root mean square. If there is one given, then you need to directly use these two equations, calculate the maximum and report the value.
Yes, exactly,
Okay.
sir.
In IS code, we use cube strength as a base, but ACI says to use cylindrical compressive strength. You
Yes,
might
sir.
you might be getting confused like in between IS and ACI code. That conversion that we talked about point 0.8, it is for IS code,
Hmm.
like in practical
Yeah,
cases when we report the value.
yeah. I think, sir, in question, if they given the compressive strength as per cubic, then you have to convert it into cylinder. Then after that, you have to proceed with the
Like
steps.
generally, if it is a design problem for ACI code, they will mention in cylinder only. They won't
Cylinder.
confuse you like that. If it is
Yes, yes,
mentioned
okay.
for IS code, they will mention the cubic strength
Yes.
only. That
Okay, sir.
confusion won't be created. Okay.
Yes, sir.
Just
Yes, sir.
try to solve this question again. Don't do any conversion from cylinder to cube. Just use the cubic strength and take root mean square, not just under root of S1 square plus S2 square. It is under root of S1 square plus S2 square upon 2. Okay, here also you can see, suppose my x1 and x2 are very close. So this final term that is there, it will become 0. Okay, n1 minus 1, so it will be 14 into s1 square plus 14 into s2 square upon 30 minus 1, 29. So 14, if I will take common, so 14 upon 25 is approximately 2. So that's why they take, you can take root mean square as a shortcut. Okay, so that's how that concept came, why we are taking root mean square. Okay, actual formula is this. So this is kind of complex formula that you don't need to remember, but just remember whatever they are saying about root mean square, it is just an approximate thing. Clear with the questions? Okay, so let's move ahead. Now let's cover the remaining part from the last session that was left. Okay, so till date we have talked about individual materials, their properties, and how raw material can be engineered in a specific proportion to form a concrete of a specific performance requirement. Okay, now from design standards we estimate the proportion of different raw materials. But once designing is done and trials are conducted to validate the design, the next step is to actually cast the concrete on field. And for this, the first step is batching of raw materials. Okay, so batching is a process of measurement of specific quantities of ingredient of concrete like cement, aggregate, water, and admixture in a correct proportion as determined during the mixture design of concrete. Okay, now why do we require batching? Okay, because from mixture proportion we'll get a quantity of each material per meter cube of concrete. So if you remember, whenever we talk about concrete proportioning, we consider 1 meter cube of concrete. However, in reality we may require more quantity of concrete, or my mixer in which I will mix all the ingredients, it may not be capable of mixing 1 meter cube of concrete at once. Okay, so we need to take all the ingredients as per batch capacity. Okay, so suppose my mixture has a capacity of 0.5 meter cube. Okay, and I have prepared a mixture design of 1 meter cube. So all the proportions that I have calculated, I need to divide it by 2 so that I can feed in my mixer at once and make a concrete out of it. Okay, now this batching that we do, like for mixture proportion, this batching can be done in two ways. Either we can do a VA batching or we can do a volumetric batching. Okay, in volumetric batching we use measuring boxes, buckets, and other volumetric container to take weights of individual components. Okay, however, this kind of batching, it is less precise and it may lead to variation in mixture proportion. Okay, and that's why it is just suitable for small scale project and less critical works. Okay, however, on the other hand, way batching, which is actually recommended by IS 456 should to be used, we measure ingredients here by taking weight using weighing scale or load cell, and this is more accurate and ensures consistency in mixed proportions, and thus they are suitable for large scale projects and RMCs. Okay, so One of the images here shows volumetric batching using measurement box. So you can see here we have a measurements box. So what we do, we take the component, like suppose aggregate, we pour it in a fixed volume box. That you can see, this wooden box, it has a fixed volume, okay, up till the top, and then we level the top. Okay, however, here the problem can be compaction. Like different degree of compaction may result in different quantity of aggregate in the measurement box, which is undesirable and which can lead to errors in mixture proportioning. So the box tool is a concrete, so this is not a accurate method of weighing. However, if you see this second image, this is a box tool. Okay, this is known as a box tool. Okay, so it is used for way batching of concrete component, and which is mainly used for aggregate batching. Okay, so you can see there are two openings in this. Okay, and through which aggregates are poured, and a particular weight of aggregate is then measured for the concrete mix. Okay, so this is known as way batching, and this is known as volumetric batching. And in the top image you can see how a batching plant on site looks like. So there are big cylinders here. Okay, these big cylinder silos are, they are used for storing cement, and there may be other mineral admixtures like fly ash and slag also, for which this silos can be used. Okay, there are quarries here which are used to store aggregates separated by walls. Okay, there will be some water storing tank also, and other silos for storing chemical admixture. And then at the top you can see there is a control unit which takes care of weighing, weigh batching and proportioning. So control unit collects all the different raw materials in specific proportion from unit storage, and it pour them into a concrete mixture, which after mixing is ready to be taken to site for to be poured in the foam work. So you can see in this image also we have aggregate weighing. Okay, we have water which is weighed, cement silos from which different types of cement are proportioned and weighed, admixtures are proportioned and weighed. This is a mixture in which concrete is mixed and then it is transported to the site. Okay, so this is the process of batching of concrete. Now, often we do weigh batching. Okay, whenever we do wave etching, there can be chance that we record error in measurements. Okay, now up to what extent this error can be neglected is known as tolerance. Okay, so the extent to which we can neglect the error in the wave batching is known as tolerance. So as per IS 4925 clause 6.1.1, for individual batcher the following tolerance limits shall apply based on the required weight of material being weighed, weight of material in weight. So like for different types of material, there are different tolerance limit that has been specified by IS 4925. For cement and other cementitious material, it is 1%. Sand and aggregate is it is 2%. For water, it is 1%, and for admixture, it is 3%. Okay. Now, again, as per clause 6.1.3 of the same IS code, the minimum weight of any material weight to which this above tolerance limit determined applies is this given by this formula. W is equal to zero point 0.3 into R upon T. So there W is the minimum weight of material that we need to take in kg. R is the scale capacity, like the weighing scale that we are using, what is the capacity of that weighing scale, and T is the weight tolerance limit that we get from this table. Okay, how this formula work? So let's assume the weighing capacity, the scale capacity of my weighing balance is 1000 kg, and the weight tolerance limit is 2% for aggregate. Okay, so if I will use this formula, it will come out to be zero point 0.3 into 1000 upon 2. Okay, so this value will come out to be 150 kg. So for this scale of 1000 kg, a minimum weight of material that should be weighed for the above tolerance limit to apply is 150 kg. If a weight lower than this is taken, then the accuracy of weighing may not be reliable as per standard. So this is how this concept works. Now, after batching is done, for mixing concrete, there are different types of concrete mixer. Okay, and these concrete mixers are generally classified into two categories. We have batch mixers and we have continuous mixers. Okay, so in batch mixer, I can have pan type mixer or drum type mixer. In drum type, there is tilting drum, non-tilting drum, and reversible drum. And in continuous, it is just a single category, continuous. Okay, so in batch mixture, what happens after pouring all the materials into pan or drum? It mixes all those material in some time, and it finally discharges. And this process is limited until the required amount of concrete mix is obtained. So suppose I want 4 meter cube of concrete. Okay, however, my mixer has a capacity of only zero point 0.5 meter cube at once. So in batch mixer, I will mix zero point 0.5. I will dispatch this. I will then mix more zero point 0.5 and then I will discharge it, and this I will repeat up till I obtain a 4 meter cube discharge. Okay, so this is known as batch mixer. However, in continuous mixer, this loading, mixing, and discharging of mix is done continuously until the work is completed or some break is taken in between work. Okay, and such mixers like continuous mixers, they are used for very large scale projects like dam, bridges, and construction of high rise buildings. Okay, so let's see these mixers to images. So first are the cases of drum type mixtures in which concrete ingredients are mixed in a drum, which is actually in the shape of a double conical frustum. So you can see here it is a double conical frustum. Okay, all the three drum mixers that we are discussing all are in the shape of a double conical frustum. Okay, so we can see this in three images, like three types of drum. So we have tilting drum mixer. Okay, we have non-tilting drum mixer. Okay, and we have a reversible drum mixer. Okay, so in tilting drum mixer, what happens? The drum will discharge concrete by tilting downwards. Okay, it has a ability of like rapid discharge. Okay, and it is like often used for large scale projects. So, and generally we use like low workable concrete with a higher aggregate grade in this mixture, because for more workable it may encounter problem of segregation. Like suppose you are pouring material from the top, and for discharging when you are tilting it, if you have a more workable mix, what will happen? Your ingredients in the concrete batch may separate while discharging. So that's why it is generally used for a low workability mix. Okay, in this image you can see how this procedure happens. Okay, so when this is facing upward, we pour the material. For mixing, it is generally kept horizontal, and for discharging, it is tilted downward. Okay, so this is known as tilting type drum mixer. Okay, now the second one is non-tilting type drum discharge. Okay, so in this, mixture is not allowed to tilt, and drum rotates around its horizontal axis. Okay, and for discharge, there is a blade that is arranged in an inclined position, which like receives the concrete mix from the drum and discharges is out. Okay, so like there can be a blade also, or there can be some mechanical drive also to push the material out, anything we can use. Okay, so in this image at the top you can see one clear way how this mixture works. So from the top we pour the material, here mixing happens, and this is the exit from the bottom. Okay, or there can be a mechanical drive also, like after mixing it will push the material out from the same side. So both ways it is possible. Okay, and since we are not tilting or doing anything here, we can use higher workable mix also in the such mixtures, and it is generally used for some large scale project where we want to rapidly discharge concrete. Now the third type of drum mixer that we can see, it is like a reversible drum mixer. So it is similar to this non-tilting type. Okay, what is the difference in this? When the material is poured and when the material is discharged, the direction of mixing changes. Okay, so my rotation of drum is opposite when my I am pouring the material and when I am discharging the material. Okay, so like it will rotate in a clockwise direction for mixing, and for discharging it will rotate in a anti-clockwise direction. So that's why it is used for. It is known as a reversible type mixer. Okay, after drum mixer, you can see this is pan mixer. Okay, so it consists of a circular pan in which concrete is mixed. Okay, mixing is done by these blades. Okay, you can see here also blades, and here also there are blades which are there. Okay, and there are two types of pan mixer which are available. Like in one case the pan is constant and only the blade is rotating, or my blade is constant and the pan rotates. Okay, so based on this rotation the mixing happens, and it is like a more efficient and more practical way of mixing. Okay, so generally all type of batch mixture, they are efficient type only, and they can be used easily for concrete mix, however for a lower quantity, because you can see there is not much volume available for mixing here. Okay, and this last image you can see a continuous mixture. Okay, so as the name suggests, here the loading, mixing, and unloading is done continuously until the job is complete, and that's why it is used for large scale projects like dams, bridges, and high rise buildings. Okay, now, once we have batched the material and poured the material in the desired concrete mixer, the next thing is how much time, for how much time we need to do mixing. Okay, so what IS 4925 code says, the minimum mixing time for each batch, provided that all the mixing water shall be introduced before one fourth of the mixing time, it is this values. Okay, so 1.5 minutes if my capacity of mixture capacity is 2 meter cube, 2 minutes if my mixture capacity is 3 meter cube, and 2.5 minutes if my mixture capacity is 4 meter cube. Okay, and IS 456 also says that overall mixing time should not be it should be at least 2 minutes. So it should not be less than 2 minutes. Okay, so it is like generally said that if we increase the mixture time, we will get a more uniform mix and a more uniform distribution of hydration product, which can result in a higher strength. However, if we'll mix for a very long time, it may not increase the strength proportionally, and it can also decrease the strength. Why? Because there can be over grinding of material, which can increase the proportion of fine, or there can be excessive mixing, which can lead to segregation in a like higher workability concrete. So it is not like, oh, every time if we increase the mixing time we will get a better strength. After a certain time my mixing time can also decrease the strength. Okay, but however up till a certain mixing time, you will observe a more uniform distribution of hydration product. Okay, now try to answer these two questions based on batching and mixing, and if you have any doubts in the batching and mixing part, you can ask now. Which type of mixture is good? Like it is it depends upon the concrete quality that you are using. It is not like one is good, one is bad, all are good, but it depends upon the aggregate size that we are using, the workability that we want from the mix, and yes, these two things, and mainly the speed of mixing that we are working at. Okay, so as I told you here, like this tilting drum, here if you are using a high workable concrete, you may see segregation happening. However, for low workable concrete, it is good enough. For this non-tilting drum, you can go with the high workable concrete also, because you are not tilting the drum, you are escaping as it is from the bottom. This reversible drum, it is mainly used for dry mixing. Okay, it can be used for that. This pan mixture, it is the most efficient type. Okay, more efficient than drum mixer, this pan mixture, because there's proper scratching, rubbing of concrete that is happening. Okay, and this continuous mixture, it is used for large scale project where you want to rapidly discharge your material. So based upon the project requirement, the material constraint, the choice of mixer can change. Sir, at the last, please help in solving the assignment. I am not able to the three parts of new. Okay, that we will see in the end. Okay. Generally, we add the dry ingredient first, then we do a dry mixing, and then we slowly add the water and do the wet mixing. Okay, and like for chemical admixtures, they are not added separately. They should be mixed in water and then added. Okay, so first we'll add all the dry mix, mineral admixture, aggregate, cement, everything, and then we'll add water. And chemical admixtures we add by dissolving in water, not separately. Like suppose you're adding SP, 1% SP, suppose 20 gram. So you won't add 20 grams SP separately. You need to preserve some water for SP, and you need to dissolve your SP in water and then add in concrete. So generally it is the dry part first and then the water and SP part. Try to answer these two questions. So, what will be the answer for first question? In a fully automated batching plant, which system is used for precise measurement of material? Can anyone tell me the answer?
Load cells, maybe.
Anyone else? Okay, so the correct answer is load cell. Why? Because how load cell operate, they convert the mechanical force into an electrical signal, which gives us the reading of what material we are weighing. Okay, so this is like this ensures that there is accuracy in measurement of cement, aggregate, water, admixture, whatever we are using. Okay, so among all the choices that I have mentioned here, the load cell is the most accurate measurement system. Okay. Now, for the second question, can anyone tell me the answer? What is the primary advantage of using a twin shaft mixer over a drum mixer in concrete production?
So it will be option 3, prevents segregation of aggregates in the mix.
Anyone else? Okay, so this segregation thing will only happen when you are using a high workability mix. Okay, generally, my twin shaft mixture, it gives me faster mixing time and uniformity. Okay, as I told you here, this is more efficient in mixing. So twin shaft is, it is the pan type mixer that we are talking. Okay, and this is the drum type mixture. Okay, so they generally give me a faster mixing time and uniformity. It is more efficient in for mixing in a twin shaft. Why? Because then since they are like they are more efficient, they are used for high performance concrete. Okay, and they like since they are giving me uniformity, they can prevent any type of segregation also. So this can also be a correct answer, because when we are talking about uniformity, we are saying prevention of segregation only. But like it also gives us this added benefit of faster mixing time, because my mix is happening more efficiently. So mixing time can be reduced compared to what is there in a drum type mixer. Okay, now answer this third question. In a high performance concrete mix, which of the following, which factor has the most significant effect on the mixing efficiency? So can anyone tell me the answer for this? Okay, so the correct answer will be A, the sequence of material addition. So as I talked just a few moments ago, the order of material addition can play a important role in ensuring like there is proper dispersion. So generally, first we add all the cement, mineral admixture, aggregate, we do a dry mix, and then we need to add SPN water. and sp should be dissolved in water and then added. If we use an incorrect sequence of material addition, then it may result in poor workability, inadequate mixing, and inefficient hydration after mixing. Okay, so sequence of material addition also becomes important. Now, question 4: what is the primary purpose of retention period in a concrete mixing cycle? Okay, this is something that I have not told you during the mixing, but try to answer. So, like generally, when we are doing mixing of a concrete proportions, there is some retention period also. Like we stop the mixing for a while and then we resume the mixing. So, what is that reason of retention period? Okay, so the correct answer for this is B. To ensure admixtures fully react before placement. So here admixtures that we are talking about, it is chemical admixture. Okay, so what happens? Retention period allows the chemical admixture like superplasticizers to fully disperse and react with the cement particle before the mix is discharged. And this enhances the workability and uniformity of my concrete mix. Okay, so that's why generally when we are using a superplasticizer, there is something known as retention period also that helps us to see whether how workable my concrete is becoming. Okay, as it allows my sp to disperse and react with cement properly. Now answer this last question before we move ahead again. Which mixing method is most suitable for ultra high performance production? So can anyone answer this question? Fifth question: which mixing will be suitable for ultra high performance concrete? Most suitable. Okay, so the correct answer will
Pan mixer
pan
with
mixer.
high
Okay.
erection.
Why? Because when we use pan mixer, there is like rubbing of concrete particles with each other, which gives intense shear action and ensures there is proper blend of fine powder fibers. If we use an ultra high performance, fibers are also used. There are admixtures also used, and this high shearing action, it provides all the necessary action to like completely mix my concrete in a homogeneous and a dense manner. So for ultra high performance, which it is more suitable to use a pan mixture for efficient mixing. Okay. Now, once the mixing is done, it is time for the post mixing operation, which involves transportation, pumping, compaction, and curing of concrete. Okay, so we'll see each of these operations separately in detail, like mainly through images, not through text, to understand different ways in which these operations are accomplished. Okay, now for conventional concrete, mixing and transportation is a separate thing. So we do mixing at the batching site, and then the concrete is transported on the site. Okay, however, when mixing and transportation is done together, it is known as a ready mix concrete. Okay, so if we go by a standard definition of what ready mix concrete is, so as per IS 4926, a ready mix concrete is a concrete delivered at site or into the purchaser's vehicle in a plastic condition. Plastic means flowable condition. Okay, and requiring no further treatment before being placed in a position in which it needs to be set in. hardened. Okay, so in ready mix concrete, what happens? This mixing and transportation, it is done together till the site. Okay, so we can understand this through the this image also. So here you can see we have a site location, okay, where we need to pour the concrete, either during the construction, or like it can be during some post construction repair work also, where we need concrete. Okay, there is a transportation vehicle. Okay, there is a vehicle over which there is a concrete mixer attached, which is delivering a ready mix concrete in a plastic state. Okay, that is like before setting, this concrete needs to be delivered so that it can be poured directly into the required location. Okay, so we have a transporting vehicle, we have a site location. This is a concrete mixer, and this is my ready mix concrete, which is poured into the site location. Now, this mixture truck, loaded truck, is the key behind a ready mix concrete. Okay, so in this figure, you can see there is a truck. Okay, and with the drum attached to it. Inside the drum, we have mixer's spiral, where concrete is mixed continuously during the transportation. And once the truck reaches the site, there is a discharge, a panel through which concrete is unloaded and poured into the site. Okay, so this truck setup is commonly known as agitator truck. Okay, so this is known as agitator truck. Okay, now there can be three types of ready mix concrete based on the mixing operation. Okay, there is transit mixed concrete, okay, where complete mixing is done in the agitator truck during transportation. There is shrink mixed concrete, where partial mixing is done at the batching station and remaining mixing is done inside this truck. And there is central mixed concrete, where complete mixing is done at the batching station and it is just loaded into the agitator truck. Okay, so based on this, so these are three different types of RMC. Now, the choice between these three types depends upon various factors like distance, project size, quality control, and site location. Okay, site conditions also. So this transit mix, it is used for long distance transportation for like medium scale projects, small to medium scale project. Why? Because it offers some flexibility in mixing. Like suppose on reaching the site, the engineer finds that the mix is stiff and not adequate in terms of workability, so SP can be added during the transit. Okay, so that gives me the flexibility in my RMC. Second, shrink mix. Why it is called shrink? Because partial mixing is done at the batching plant. So since partial mixing is done, the bulkiness of my concrete mix during transit, it will reduce. Okay, and that's why it is known as a shrink mix concrete. And this is commonly used for moderate distance transportation, like for medium to large scale projects. And finally, we have a central mixed system which offers a high quality control. Okay, so compared to other two, central mix systems offers a higher quality control and consistent concrete, and it is used for large scale project. However, for a shorter transport distance only. Why? Because my mix is already prepared and I'm just transporting. Okay, and if my transportation time will be long, I will start recording loss in plasticity that I don't want. So that's why it is generally limited to a shorter transportation time. However, it offers high quality control and a consistent concrete, which are the additional advantage of central mixed concrete. So in this way, an RMC application can vary based on different factors. Now, what are the benefits of using RMC? It increases the speed of construction, since two things are working together. It reduces the demand of storage space on site, since we don't need to store anything on site. We are directly using a ready mix concrete. Then it won't require any site storage space. It has less dependency on labor, which reduces the chances of human errors. It can be versatile for both small scale and large scale concreting that we saw earlier based on the mixing truck, and ensures better handling and proper mixing, which can reduce my cement and admixture demand also. However, However, at the same time, the use of RMC can be detrimental also. Why? Due to chances of loss in sum during transit. Suppose we have a higher than expected transit time. Okay, so for transfer of concrete from preparation site to delivery site. Okay, so it will result in a loss of workability. And how this higher than expected transit time can occur? Due to unexpected traffic during transit, due to lack of planning of slump retention prior to transit, or due to lack of preparation of homework and transportation resources at the construction site. So these reasons can lead to higher transit time, and if the transit time is more than what it was planned for, then we can record loss in slump. Okay, and if we record loss in slump, when we are pouring our ready mix concrete inside the formwork, it won't compact properly and it will give me compactability issue in the concrete, which may not yield the performance that I want from concrete. Okay, so though ready mix concrete has several advantages, the loss of slump can be a disadvantage that can come if the planning is not done properly. Okay, so if we are recording loss system, then what we need, we can demand for additional water and admixture to maintain the workability before pouring, or at site we require some quality control engineers to check the workability using slump test before it is used for construction. Okay, so these are the precautions that we need to take, okay, within ready mix concrete. So the effect of transits time and slump loss you can see here also. So with increasing time of fall, as my hydration proceeds, my slump value will decrease continuously. Okay. Now, if for enhancing the slump again, instead of SP we are adding water, then the amount of retempering water will directly result in the strength loss. Why? Because we are increasing the water to cement ratio. Okay. So this was the that is how my RMC can be detrimental. Okay, and this was about RMC, like different application ways, benefits, and its negative effect. Now, for transportation of conventional concrete from mixing plant to a structural element that is enclosed in a formwork, there are different ways. First is wheelbarrow and mortar pan. Okay, so these are like some old and commonly used methods which are mostly used for short distance transport and small scale projects. So for small scale and short distance, we are using this. Then we have bucket uh, transport through ropes, which is again commonly used for large scale projects like high rise building. There is conveyor belts, which are often used for horizontal distance transport for mixing station to pouring station. Like a conveyor belt can also be used in an RMC, like to move concrete from a agitator truck to the pour location. For that also we can use conveyor belt. Then there is transit mixer that we have already seen, used for transportation of RMC, or maybe conventional concrete also if we are mixing at the batching type and the truck is just needed for transport, like we saw in the last point here, central mixed concrete. So for that we have transit mixture also for transportation of concrete. And then the most commonly used is pumps and pipelines. So from truck using a pump, the concrete is forced through the pipeline to move horizontally or vertically to its desired location. Okay, so in this way there are different ways in which concrete can be transported based on my project size and project constraints. Now try to answer these three questions first based on RNC and transportation. And if you have any doubt in RNC and transportation, you can ask now. Let me check for any question if it is there. Sir, retards have to mix during the mixing of concrete at RMC or in transit. See, when we are planning for transportation, we plan for slump retention also. Like suppose on a mixing plant, I have prepared a concrete mix and I know that this concrete mix will take 60 minutes or 100 minutes for transport. So after 100 minute, how much workability I want, that I need to plan prior to transport. So suppose during mixing I have a workability of 100 mm slump I am recording. It is not uh, True that that 100 work slump I will get after 1 hour also. After 1 hour, my slump may be 20 only or 30 only. So initially, my concrete should have a slump of 150 to 200 so that when it is pouring, it has a slump of 100 which was actually required from concrete. So in this way, we need to manage the SP dosage. Okay. Now suppose my transportation time is more than what I desired for, then my 100 slump will become 70 or 60 during pouring, which I don't want. So that's why we need proper engineers which can control my concrete. So before it is taken out from the agitator truck, we can add a little more SP to increase my slump back to 100 for pouring. So that's how RMC operate. Okay. For unplanned action, there should be like precautions that plan, like there should be engineers who can take unplanned action if some error occurs during transportation. Okay, can anyone answer the first question? Which of the following is the primary advantage of using RMC over site mixed concrete?
Sir, according to this, then the most of the that RMC plant they don't they try to avoid the use of retarders, right, sir?
Retarders, yes, they can avoid. RMC is generally like it depends. It depends upon the transportation distance also. Like we discussed three types of RMC: long distance, moderate distance, short distance. So in short distance, you can use retarder. It depends upon the site location, the external conditions, which type of superplasticizer you need. If the
Okay, sir.
transportation distance is very short, then slump loss you won't face any issue of slump loss. Then retarder may be used if it is needed. Like when you want your concrete to set fast, then you need a retarder, accelerator, sorry.
Yeah. So yes, if the traveling distance is too high, then more than second time, then how they will?
That's why we
Uh,
use SP na, to keep my concrete workable for a longer time.
then what about the strength and durability? Because the dosage will be over, no, compared to
See,
the.
SP, if we are not changing the W by C ratio, the strength won't be affected. SP is just for workability. If you go back to the discussion that we had of superplasticizer, I showed you one chart
But
where we said for
right,
the
sir.
same
But the
strength.
super classes are also you have to use a certain limit, no, sir. If it is exceed the limit, then it is
So that thing you
that
need to
reversible
manage.
effect will
That
happen.
thing they manage.
Yes.
It is like that limit is not small. That is not like at 0.9% SP you're getting workable and at 1% it is bleeding. Generally, the SP demand will be much lower than what is the ultimate limit. Okay, so that thing is more managed well when actual concreting is done. Like suppose you want a flowable mix, you may require 150 to 200 slump. For that SP demand, you can add SP. It won't show you any bleeding. If you add more than twice of that SP, then it may show you bleeding. So that thing is managed well during mixing.
Okay, okay, sir.
Try to answer this first question quickly now. Which of the following is the which of the following is a primary advantage of using RMC over site mixed concrete?
Uniform quality and better strength.
Okay, so the correct answer is uniform quality and better strength. Why? Because RMC is produced in a controlled condition at a batching plant, and it ensures that there is a consistent quality and strength. Okay, as it will eliminate any variability in the mixing, which can occur in a site mixed concrete. Okay, at site when I'm proportioning my concrete, I can have some variability in the proportion which is eliminated during RMC. Now, second, what is the typical time limit within which RMC should be discharged from truck mixture to prevent sitting?
30 minutes. 30 minutes.
Any other answer? Okay, so like this question may not have a definite answer. Okay, but conventional practice says that RMC should be prepared dispatched within 90 minutes from the time of batching to prevent any premature setting or loss of workability. Now, this time may vary slightly depending upon the condition, temperature, mixture design, but generally in RMC, since superplasticizers are used to ensure workability, they are generally said that they should be discharged into the formwork within 90 minutes. 30 minutes can also be the answer. It will depend upon the site condition, but general practice is 90 minutes. Conventional practice. Question 8. Which of the following
Pumping.
transportation method is most best suited for large scale high rise construction project?
Pumping.
Okay. So for 8, answer will be pumping. It is the most efficient method. Why? Because it allows concrete to be transported both horizontally and vertically to a larger distance with any minimal effort. Other methods like wheelbarrow, dumpers, wheelbarrow, dampers, and belt conveyors, they are also suited, but for short distance and ground level work. Okay, for large scale and high rise construction, pumping will be more suitable. Now, answer to these two questions: which of the following factor has the greatest impact on concrete workability during transit? So this should be an easy answer for you from what we have discussed till now.
Uh, Transit time and temperature.
Okay, try to write your answer in the chat box now so that others can also answer in the meantime. Okay, can I see answers for question number 9? Okay, so the correct answer is transit time and temperature. Why? Because as we have seen in our discussion, longer transit time will lead to loss in slump, while higher temperature can also accelerate the hydration reaction and reduce my workability. So this will have the greatest impact on workability during transit. Now, question number 10. In the case of using a belt conveyor for transporting concrete, which of the following measure is more effective if is most effective in preventing segregation? So when you're transporting your concrete through a belt conveyor, which practice is most effective for preventing segregation in your mix that you're transporting?
Sir, option B.
Anyone else?
B answer, sir. Using a narrow belt wide.
Okay, so the correct answer is C for this question. Say why. When concrete is transported on a belt conveyor, if my slope of belt is steep, like suppose if my slope is like this, what will happen? There are chances that segregation can occur because aggregates will roll down faster compared to my cement pace. So if my slope is slow, there is chance that there will be even distribution of my mixture component at the end of the conveyor belt. Narrow belt or a wide belt, it won't matter. The slope will be more critical to prevent segregation. The narrow belt and the wider belt, it will just make a difference in the quality of concrete that is getting transported at a time. Quantity, but the quality can be affected by the slope of my belt conveyor. If it is steep, then segregation chances will be more. Okay, so let's move ahead. Now, One part in transportation that we need to discuss is pumping. Okay, but before moving into pumping of concrete, let's discuss one important part of concrete which affects the transportation, which is workability of concrete. So, workability refers to how easily my freshly mixed concrete can be placed, compacted, and finished without any segregation or excessive bleeding. Okay, and this workability is made of three components. It is based on compactability, mobility, and stability. So, compactability, it refers to the ability of concrete to be compacted by a given amount of work to achieve full density. So, when I pour the concrete inside a formwork or inside a mold, how well my concrete will get compacted when I will apply some force on it. So, that is referred as compactability. Okay, and this is given by this formula, general formula. Scientific representation of compactability is based on the shear strength, the viscosity, the yield strength, viscosity, shear strength, density, and gravity. Okay, so these parameters play a key role in the compactability of my concrete. So these are all rheological parameters that we are talking about, and these are material property, and this is gravity, which will govern the flow of my concrete inside inside a formwork or a mold. Okay. Second is mobility, the ease with which concrete can flow and place around a reinforcement or a formwork. Suppose this is my formwork, and these are reinforcements that are there. So mobility refers to with what ease my concrete is flowing through this portions, restricted portion inside the formwork to move to each and every corner. Okay, so that is referred to as mobility. Okay, without any compaction force being applied, how well my concrete is flowing on its own. Okay, and that will depend upon the viscosity, yield strength, and the maximum aggregate size. Okay, so we have seen earlier, like in ACI method for defining workability, they use criteria of maximum aggregate size also. Why? Because it will define the mobility of my concrete in in some restricted condition, and shear strength and viscosity also, it governs how the flow of my material. Okay, and then stability, resistance of fresh concrete to bleeding and segregation. So once my concrete is placed and it is compacted, how stable is my concrete to separation, that is defined by stability, and it will depend upon the tensile strength of my cement paste to resist any segregation from occurring. Now, these three components of workability, they are important to ensure good quality and durability of my concrete. Okay, compactability ensures that my concrete is fully compacted with minimum effort required. Mobility allows that my concrete is freely flowable. Okay, making placement of concrete efficient, and there are less defects inside the formwork, and stability prevents segregation and bleeding. Okay, which helps us me to maintain a uniform mix after compaction is applied. And these three combined define the workability of my fresh concrete. Can you mute yourself? Whose mic is on? Okay. Now, for different types of construction work, my workability requirement can change. Like for pavements and RCC slab, RC slab, it is not RCC, we generally say RC slab, we require a medium workability. For heavily reinforced structure, I require a high workability. And for mass concreting, like for dams and foundation, I generally require a low workability. Therefore, it is important to ensure that the concrete has a adequate workability before it is pumped or by any mean transported inside the formwork. So, depending upon my project type, my workability needs to be maintained properly. Now, to measure workability of concrete, there are different testing methods that are used for different types of concrete. So we have slump test, which is used for normal concrete, and we measure concrete slump when it is poured in a conical shaped mold. Okay, so if there is higher slump, it means more workable concrete. Then there is compacting factor test, which is used for low workability concrete. to measure the degree of compaction under a standard effort. There's flow table test, which is used for very fluid concrete to measure how much concrete will spread when vibrated. And there's VB consistometer test, which is used for very stiff concrete, which measures the time taken by concrete to change its shape under vibration. So just don't go to the description part that we'll discuss right now again in detail. Just remember there are four testing methods. However, each of the testing method it varies for the type of concrete that we have. If we have a normal concrete, we can use slump test. If we have a very flowable concrete, we use a flow table test. If we have a very stiff concrete, we are using a VB consistometer test. And if we have a low workability concrete, we use compacting factor test. So based upon my concrete type, the measurement of workability, the testing for measuring workability can change. Now in this slide, you can see slump test being performed. So for slump test, we have a conical flask like this, okay, which is held tightly using the legs on a flat surface. Okay, now step 1, 2, and 3 is to fill the concrete inside the cone in three levels. You can see first level, second level, and third level. After each level of filling, we do 25 tamping, okay, to ensure that my concrete is properly filled, properly compacted after filling each layer. Okay, once my concrete is filled till the top, I will level to remove this extra part from the top. Now step 4, you can see leveling is done. Then this cone is lifted vertically without any jerk. Okay, so without any jerk means that my lift should be clean, vertical, and continuous. It should not be like we have lifted to a certain height, then we stop, then we lift it again. At once, vertically, you need to lift without any jerk. Okay, and that is step 5. Upon lifting the cone, what will happen? Concrete will tend to slump or it will tend to collapse. Okay, under its own weight and due to gravity. So the amount of collapse, that is the level of decrease from the original height, is recorded, and this is reported as slump value. Okay. Now this collapse of concrete that is shown in step 6, it can be of different nature. My slump is said to be true slump if there is only vertical deviation in concrete and no horizontal deviation is happening. Okay, if there is such concrete, it means okay. So this is known as true slump. Then my slump is said to be zero when there is no vertical deviation in concrete, and this means that my concrete is stiff, and it is like it has almost zero workability. Then my slump is said to be complete collapsed slump when the vertical deviation is completely till the floor level. This means that the slump value is pretty high and concrete is said to be a collapsible concrete. Okay, so it has a very high slump value, very high flowability. And finally, the slump can observe some shear deformation also, like vertical deviation is not uniform, and this occurs when my concrete lacks some cohesion and there is a segregation in my concrete. So if there is lack of cohesion and segregation in concrete, I can observe a shear slump. And if such slump is recorded, the test should be repeated, and if it happens again, then the mix should be modified by adding like more fines or by reducing the water content. You need to modify the mix, so this is not desirable. However, these three can be desirable based on the workability level you are targeting for. Then we have compaction factor testing. So in the first image, you can see a compacting factor apparatus. So what happens? My concrete is filled in the top bucket, okay, and it is allowed to fall in the second hopper. So okay, now this fall it brings some compaction with it. Now once my concrete is, and then again from the second hopper we fill the concrete into a cylindrical mold. Once this concrete is it enters the cylindrical mold, we need to strike off the excess concrete from the top, and they record the weight as W1. Okay, So once we have poured the concrete here, we'll strike off the excess concrete from the top and record the weight as W1. Then we'll completely compact the concrete, and then again we'll fill the extra concrete from the top, level it, and record the weight as W2. So W1 is like after free fall, how much concrete has entered the cylindrical mold. Suppose it is 4 kg. Okay, after striking off the surface without providing any compaction further. Now, this the same concrete I will compact by providing some vibration energy. So under vibration, what will happen? If the compaction was not complete, my height material will become more dense, so there will be space created at the top. So in that space I will pour more concrete and I will level the surface back, and I will again take the W2. So W2, it may become 5 kg or 6 kg or 7 kg depending on the compatibility. So this ratio of W1 and W2, it is known as the compaction factor. Okay, so this is compaction factor testing. Now in the second image, we have the flow table, okay, which is used for a high workability mixture. So here, unlike recording the height of fall that we did in the slump test, using the same process, we now record the spread of concrete. So you can see here, concrete was filled. I will lift the slump code vertically upward, and once I lift the slump code, I will see that my concrete has completely collapsed and it is spreading. So instead of recording the depth of collapse, I will record the spread of collapse, and will report it as slump value. So this is known as flow table test. And finally, we have VB consistometer test. So in this, we have a cylindrical mold. You can see there is one cylindrical mold over which my slump cone is there. So inside the cylindrical mold, I have placed a slump cone. Now, using this slump cone, I will fill the concrete inside. So inside this slump cone, I will fill the concrete in 3 layers. Okay. And I will lift the concrete and allow concrete to collapse under its own gravity, under its own weight and gravity up to a certain depth. Okay. So suppose after lifting the cone, my concrete collapse up till this level. Okay. Now I have a glass disc that I will place on the top of this concrete, and I will do vibration using the vibration table. So when I will do the vibration, what will happen? There are still spaces left on the sides inside my cylindrical mold. So under vibration, what will happen? My concrete will spread in this direction and its height will decrease. Okay. So what this test says, the amount of time taken by concrete to completely collapse and reach this state is determined as the VB time. Okay, so this is known as VB consistometer testing. So I have filled my concrete inside this slump cone. I lift the slump cone and allow the concrete to collapse under its own weight. Once it is settled, I will place a glass disc on the top and I will apply vibration. Under vibration, it will compact further, and I will record the time it takes to completely compact under the cylindrical mold. So the time taken to reach from this state to this state is my VB time. Okay, and there is a table that is given in the code. Okay, so consistency of concrete versus VB time. So if my concrete takes only 2 to 3 minutes, it is semi-fluid. If it takes from 5 to 3 minutes, it is in plastic state. If it is take 5 to 10 minutes, it is dry concrete, and if it takes 10 to 20 minutes, it is very dry concrete. Okay, so based on this, we can grade our concrete into different category. So these are the ways in which workability is determined for transporting concrete. Now, one of the most famous transportation method of concrete is pumping of concrete. So pumping is used for both transporting and placement of concrete that we have seen. Okay. It combines both vertical and horizontal transport. So concrete can be pumped up to 90 to 300 meters horizontally and can be pumped up to 30 to 90 meters vertically. Pumping can place the concrete in the congested side with little excess otherwise. Okay, so we have large pumping lines available which can make help us to reach congested areas inside my concreting site easily. Small or large quantity of concrete can be placed in the formwork continuously and at a very fast rate, and this concrete flow in a pump follows a flow and the lubricated layer approach. Okay, so first see this diagram. Okay, so you can see here, this is my pump and this is my pumping line through which my concrete can flow. Now, when my concrete is flowing through this pipe, there are two portions inside my concrete. There is a lubricating layer which is near the pipeline, and there is a plug. Okay, so the plug is the concrete that matters to us. This is the actual concrete flowing, and this lubricating layer that is creating on the side, it ensures smooth conduct of concrete through the pump, which directly affects the flowability of my concrete mix. So you can see here in between, if we see, there is a pipe, there will be lubricating layer here, and there is a concrete block here. So using the pump pressure, my concrete is moving up, and due to gravity, my concrete is pulled down. So the pressure required will depend upon the quantity of concrete that I am pumping and the gravity effect on my concrete and the friction. So if there is no lubricating layer, there will be higher friction, so more pumping pressure I will require. But if there is a proper lubricating layer, there will be lower friction. So I will require less pumping pressure to pump my concrete vertically. And for horizontal also, friction will affect my pumping pressure. Okay, so this is how lubricating layer becomes important. Now there are different types of pumping system that you can see in these figure. So this is known as first is like boom or truck mounted concrete pump. Okay, so it's basically a concrete pump which is mounted on a truck with a hydraulic boom. So what is boom? A long flexible arm, like you can see here. Okay, so this is used to place concrete exactly where it is needed, which is perfect for high rise building and large areas. And the best part of such concrete pump is it is remote control, so it is safe, faster, and less labor intensive than manual pouring. Okay. Plus, since the truck can also be moved around, it is easy to pump concrete to all the locations. Okay. So you can see in the drawing also, we have a truck here, we have a boom section, and we have a pipeline through which we can easily pour concrete to any site in a high rise building also. So second is a trailer mounted concrete pump, okay, which is a compact, powerful machine which is used to pump concrete to a longer distance. Okay, so unlike boom pumps, it doesn't have a boom. Like instead, it is a towed to the side and connected to some flexible pipe that carries concrete wherever it is needed. So from this end, we connect the pipe, and this is the pump. Generates the pressure with which I want to force my concrete to move inside the pipe. This again is a high pressure trailer pump, just like a regular trailer pump, but it has extra power to push concrete to a higher distance. So based on the pressure limit, my pump can also vary. Now, the type of pump used in a trailer mounted setup, it can be of two types. It can be a single piston or a double piston. So, single piston, what happens? Concrete pump uses us one main valve to push my concrete inside the pump. Okay, inside my pipeline. So it is simple and cost effective. Like you can see here, from here my concrete is entering. Okay, this single piston, it is sucking the concrete inside here, and then it is pushing for the discharge. Okay, so this is single piston concrete pump. So it is simple and cost effective. Oh, and this in this drawing you can see a double piston concrete pump. So here you can see there are two pistons, okay, which ensures better control and efficiency. Okay, which allows for higher pressure and longer pumping distance. Also, it can be effective. So in drawing you can see there are two walls which work together. So one is sucking and one is discharging the concrete. So what happens? My concrete is pumped and discharged continuously. So when one will pump, the second will discharge. When the first will discharge, the second will pump. Okay, so in this way my concrete is pushed continuously, discharged continuously. Okay, and this ensures there is a continuous flow, whereas here there will be break in flow. So pumping will happen and then discharge will happen. Okay, so there's stop in between. After discharge it will first pump and then discharge, then it will pump and then discharge, but here it is not the case. The discharging is happening continuously and the pumping is also happening continuously. So now, based on this transportation and workability and pumping, try to answer these questions. And in the meantime, you can ask your doubts if you have any. So, okay, there are no doubts in this section. Try to answer the question number 11. Which of the following factor has the most significant effect on workability of concrete? So all will affect workability, but which has the most significant effect? Narrow opening buckets are preferred compared to wide opening buckets for placing concrete. Like I didn't got your point. Narrow opening buckets. One reason can be to like prevent segregation in narrow buckets. No, that may not be true. Let us see this question at the end. Okay, I need to ask you a few questions like which type of concrete you're talking about. Okay, let's first see these questions. Okay, for question number 11, the correct answer is B. Yes, you're right. Okay, so more water improve the workability by reducing friction. Okay, making placement of concrete easier and compact. Okay, so like when I have more water content, my lubricating layer will be more. It will be better. So it will allow smooth conduct of concrete also. So in that way also you can see. If the compacting factor of fresh concrete is found to be 0.85, what does it indicate? So what will be the answer for 12? I received one answer as B. Anyone else? So compacting factor is W1 by W2. So W1 is the weight when we have just poured the concrete inside the cylindrical mold after two falls, and W2 is the amount of concrete after fall we are vibrating and pouring additional concrete to level till the top. So that ratio is given as 0.85. Okay, so for 12 the correct answer is B. Okay, so generally compacting factor of 0.85 to 0.92, it indicates a medium workability concrete and it is suitable for reinforced concrete construction. Okay. Question number 13. If a freshly mixed concrete shows excessive segregation, which action will best improve its workability? So suppose in a mix I am observing segregation. So what action I should take to like improve the workability? Okay, so correct answer is C, using super plasticizers. Why? Because excessive segregation would have occurred if we have used too much water in the mixture. So instead of adding too much water, we should use an SP to improve the workability without increasing the water content. That will prevent segregation while maintaining the strength. Okay, so best way to improve workability is using super plasticizer rather than using more water. Okay, increasing slump won't improve segregation, reducing fine won't improve, and adding more water won't improve my workability and prevent segregation. Like both thing won't happen. But if you are using a super plasticizer inside a certain limit and reducing the use of excessive water, then I can prevent segregation also and improve workability also. Question number 14. The best way to reduce frictional loss during pumping is to. So we have seen inside a concrete pump there is the plug and there is the lubricating layer. So my plug flow is the actual concrete that is flowing and the lubricating layer is on the sides. Okay, so if my lubricating layer is weak, there is more friction. Okay, so I will require higher pumping pressure to force my concrete through a pipe. To reduce friction, what can be done? Okay, so for 14, the answer will be C, using a lubricating grout before pumping. So what lubricating grout is like basically cement slurry. Okay, if I can write in a simple term, it is cement slurry. Okay, so what the slurry does, it coats the pipe from inside, which reduces the friction and it ensures there is a smooth concrete flow that is happening. Now, question number 15. Which of the following statement is true about the pipe diameter used in pumping? Yes, Saroj, you can ask your question. What query you have? You can type your query in the chat box. I will see. Okay, so I have received few answers in the comments. For 15, answer C. Okay, that is correct. Okay, so the pipe diameter should be 3 to 4 times than the maximum aggregate. Why? To ensure that there is a smooth flow and there is no blockage inside the pipeline due to aggregates. Okay, and there is no segregation due to that. So I need to ensure my pipe diameter is 3 to 4 times the maximum aggregate size. You can write your query in the chat box, Saroj. Question number 16. Which of the following pumping method is preferred for delivering high volume concrete with minimum pulsation effect? So if you are confused by what is this pulsation effect, so pulsation effect means fluctuating flow of concrete. Like my concrete is flowing, then there is a gap, it is flowing, then there is a gap. So this is pulsation effect. Okay. So if there is fluctuation in concrete flow, it means there is that is known as pulsation effect. So I will write here fluctuating concrete flow. For 16, can anyone answer? What will the correct answer?
Double piston pump.
Okay, so the correct answer is double piston pump. Why? Because when we are using a single piston pump, there is the pump will suck the concrete in and then it will discharge. So there will be a gap in between, which will create a pulsation effect. However, in the double piston pump, there is a continuous and steady flow, which reduces pulsation and there is a efficient high volume delivery that can happen. Okay, so now after mixing, transportation, and pumping of concrete inside the formwork, the next step and often the most important step is the compaction of concrete. So what is compaction? So compaction is a process of removal of trapped air and ensuring that the concrete is dense and properly placed. Okay. Now, initially inside the formwork there is air. So suppose there is an empty formwork. So there is air inside my formwork. Now, when my concrete is poured, my air gets expelled out. However, just pouring of concrete is not enough. If compaction is not done further, there will be air voids that are remaining inside my formwork and in between my concrete, which can affect the mechanical and the durability properties of my concrete. And how this affects the performance, you can see in the images. Okay, which shows poorly compacted concrete which resulted in voids on the surface after the removal of foam. Okay, so the first image shows honeycombing. So this is known as honeycombing voids. Okay, which is like big void on the surface of concrete which are created due to inability of my concrete to flow to all confined spaces inside the formwork on its own. So inside the formwork there are reinforcements that are there. Okay, so maybe if compaction is not provided, my concrete may not be able to reach all the confined spaces inside the formwork. And when I will remove the formwork, I will see voids on the surface, and these voids are honeycomb voids. Okay, so it is due to inability of my concrete to flow to all the confined spaces. And in the second image, you can see more like a straight horizontal void strip, which we can say it is a cold joint. Okay, so what is cold joint? This is created like suppose there is a formwork. Okay, you have poured one set of concrete inside the formwork. Now, before pouring the second set, there was some halt in between. Suppose 30 minutes, 1 hour, 2 hour, there was halt in between. So what will happen due to this halt? My before my second set is poured, if it doesn't mix well with the first set, okay, due to this halt, my first concrete that was poured, it will start to set. Okay, now if before pouring my second set of concrete, the first concrete starts to set and I don't do any compaction, what will happen? There will be a joint that will be created between the first and the second concrete, and that joint will appear like a void. Okay, and that such void is known as cold joint due to incompatibility of old and new concrete inside the formwork. Okay, so here also compaction becomes important, because if we will do compaction, we will thoroughly mix this joint area and there will be no voids left. Now, more is the amount of air void, lower will be the strength, as you can see in this first figure. Okay, so to avoid this, compaction is done, which is a two-step process. So first step is known as liquefaction of concrete, which where concrete due to its slump is allowed to flow and fill the spaces inside the formwork. So suppose this is my formwork, I am pouring the concrete from the top. To due to its weight and due to gravity, my concrete will flow inside the formwork, and that is known as liquefaction of concrete. Okay, where concrete flows due to its slump and gravity. Then second step is the compaction that is done to remove all the entrapped air voids from inside the formwork. So once I have allowed my concrete to flow, okay, then I will do some external compaction to remove additional air voids that are present inside the formwork. And what is the end result? So under the same applied stress of concrete, my concrete after compaction will possess more shear strength than the concrete before compaction, like what you saw in the NPTEL session. Okay, so you can see here, before vibration, my concrete at a certain stress level has a certain shear strength. However, after compaction, you can see at the same stress level, I have my concrete has more shear strength. Okay, so that is the role of compaction. It will increase my cohesiveness of my concrete, the strength of my concrete by reducing the voids in between concrete. However, one thing you can note here, that this compaction activity should be performed only when the concrete is in plastic state and not when the concrete is set. Okay. Okay, if my concrete is set and then I am providing some compaction activity, it will only result in a negative effect. which will lead to decrease in shear strength. So you can see here, I am vibrating my concrete. Okay, I am compacting my concrete, so it is increasing the shear strength. However, if my concrete is set and then again I am applying some vibration, it will create cracks and voids. It may create cracks and voids also inside my concrete. So this compaction effort should be applied until my concrete is in plastic state and not after my concrete is set. Now, there are different ways in which compaction can be done. There is manual compaction and there is mechanical compaction. So, in manual compaction, we have rodding, like using a rod to tamp concrete in different layers. So, suppose I have filled it to half level, I will use the rod to compact, then I will fill the second half level and I will use the rod to compact. So, this is rodding. Then there is ramping, which is suitable for low workability concrete, often used in mass concrete. So in ramping, you can see this is the ramping rod using which we will hit the concrete from the top and we will compact it. Okay, and there is tamping. So you can see for slab construction, for leveling and compacting, we use a tamping tool like this. Okay, so using this, we tamp the concrete and compact it. Okay, so all these methods, they are using manpower to squeeze the concrete and release the air voids from inside. However, in mechanical compaction, we have different categories. There is internal vibrators like needle vibrator, there is external foam vibrators, there is surface vibrators, and there is vibrating table. Okay, so internal vibrator, they are inserted into the concrete to remove the air pockets. Like you can see here, these are vibrators. They are placed inside the concrete and then vibrations are provided to remove any air voids or air pockets. Then external vibrator, which are foam vibrators, you can see here. So such vibrators, they are attached to the foam work and the foams are vibrated to expel the air voids out from inside the foam. Then their surface vibrator like this you can see, where which are used for slab, roads and pavements, where on the surface vibration is provided. Since this depth of concreting element will be small, so surface vibrator will work well in such case. And this vibrating table, okay, so these are basically used for laboratory purposes. Okay, so on these tables we place our concrete filled mold and we vibrate the table. So once the table will vibrate, my molds will vibrate and the air will expel out, since my concrete will flow and try to occupy all the spaces inside the mold. Okay, so they are generally used in factories or laboratory for precast concrete elements. Now, although compaction we have seen is an important step for post concrete operation, certain application of concreting restrict that the use of any compaction. Okay, so in certain application we can't use compaction, and one such application is underwater concreting. Okay, so in underwater concreting, what happens? My concrete should be self-compacting and wet enough to flow under its own weight, and it must be placed with least disturbance. Okay, so there are different ways in which underwater concreting can be achieved, because since we are not applying any compaction, then we need to find a way so that I can place my concrete efficiently, for which there are different ways. So first is skip and bucket method. So as you can see in the image, for conveying concrete, a bucket is used which has a double door opening. So there is a door opening at the bottom also and at the top also. Okay. So once I reach a certain level inside the formwork, so this will be my formwork. Okay. Once I reach a certain level inside the formwork using a rod pulley, okay, I will open my flap. Okay, for double door, like the flaps at the bottom, they will open up, and the concrete will be poured to the this desired level without need of any much compaction or anything. Okay, if I am not raising my bucket till the bottom and if I am pouring from a certain height, what will happen? Due to the height of fall, there will be a compaction energy which will be created, which can lead to some leakage from the foam work that I don't want. So I will just automatically or manually take my bucket down to the certain level and pour the concrete and lift the bucket up. So this is known as skip and bucket method. Then second method is pre-packed aggregate and cement grouting injection. So as you can see in this method, what happens? I have a foam work and I have a coarse aggregate which are pre-packed inside the foam work. And then I will use a high flow cement grout which is injected through the voids of this aggregate system. to ensure that all the aggregates are uniformly bonded and there's minimum segregation on in or washout. Okay, so this is known as pre-packed aggregate and concrete injection, cement grouting injection. Okay, this is very commonly used method in dam construction, you can say. Third method is Tremie method, which is like widely used for underwater concreting, where concrete needs to be placed, okay, to a deeper level. So you can see here we have a vertical pipe, okay, which is known as a Tremie pipe, with its lower end submerged inside the fresh concrete. So what happens here? I will insert my Tremie pipe till the bottom of my pour location. Now I will pour my first batch of concrete on the top, which has a plug and a seal. Okay, so the first batch have a plug and a seal with it. Okay, so inside that my concrete will flow and pour. And now this end I will continuously keep it submerged inside the previous concrete. I will pour fresh concrete from the top continuously. Okay, so what happens, my fresh concrete will push the later older concrete laterally, but since my concrete is denser than water, it will try to stay in its own place, it won't move laterally much. Okay, and this, since I'm ensuring that my top of the pipe is inside the older concrete, it ensures that there is no mixing of water because of its cohesiveness, and it just settles due to gravity in a particular shape. Okay, so this is known as Tremie method, and for this I need a concrete which has a high slump, it is cohesive, and it has anti washout admixtures available. After curing and compaction, the final step is pouring and compaction. After that, the final step is curing. So curing is the process to maintain moisture and temperature condition of concrete for hydration reaction. Okay, so that concrete can develop adequate hardened property over time. So we have seen earlier also, curing period, it is the period in which my concrete gains strength. Now why curing is important? Because of following reasons: it prevents moisture loss from inside concrete. So the moisture that is there inside concrete, it is there for hydration reaction. If there is moisture loss that is happening from inside concrete, what will happen? There won't be much water available for hydration, and it can lead to shrinkage on concrete and improper strength gain inside my concrete. Okay, so I don't want my concrete to dry out prematurely, or and I want to avoid any drying shrinkage in concrete. So that's for that I need to ensure that there is proper curing. And second importance of curing is to maintain the thermal gradient. Okay, so this helps in maintaining the concrete temperature, which allows hydration process to continue. Okay, so different standard has said different things about curing period. So ACI standard says that the minimum curing period should be till the stage the concrete has achieved 70% of its compressive strength, and this is often related to 7-day curing. However, IS code says that the minimum curing period should be at least 7 days in case of OPC, 10 days in case of mineral admixture and blended cement, and it can also go up till 14 days for blended and mineral admixtures in hot and dry weather. So different codes have different limitations, like minimum time. Maximum you can keep for 20 days, even for 1 year you can keep for curing, but minimum should be this, so that there is no excessive moisture loss and change in thermal gradient. Okay, because initially when they cement hydration, there is a lot of heat of hydration that is generated inside my concrete. So if there will be a lot of thermal gradient between inside and outside, then there can also be segregation, sorry, shrinkage that can happen, that I don't want. I want to maintain the thermal gradient from the start up till a certain period where, for of curing, which is mentioned in different standard, which we need to maintain. So in this figure, you can see how different ways of curing can affect the compressive strength of concrete. Okay, so we have continuously cooked. If we will do the air curing, we can see we will only achieve 40% of the maximum strength which we would have achieved in continuous moist curing. Okay, and after different curing days, you can see how strength gain is changing. Okay, so How to do curing, it can be achieved in different ways. Okay, there is immersion curing, in which concrete is submerged inside a water tank. There is ponding, which is generally used for slab, where over the slab we with raised edges that can be created using cement slurry, we pour the concrete, which ensures that there is enough moisture available in for the slab. Okay, then there is spraying and fogging, which ensures that the concrete surface is moist, and jute bags also, which you can see in the final image, which covers the concrete and keep the concrete moist. Okay, so these are wet jute bags, which ensure that the concrete is in moist state. Another way of bonding can be membrane curing, like using plastic sheets. You can do the curing. Okay, you can use some acrylic based or some curing compound, which can be acrylic based, wax based, or resin based, which are like applied on the surface of concrete in a thin film like manner, which can prevent moisture loss. Okay, so some example of that, you can see this bituminous emulsion that is coated, then water repellent chemicals that is sprayed here on the pavement, and you can use plastic sheet also. Okay, which can prevent moisture loss from inside my concrete. Now, sometimes one may require higher strength gain also, like rapid strength gain. Okay, curing, you see, 20 days minimum are required to achieve up to 99% strength gain. But suppose I need a strength gain at a faster rate, then I need to go for steam curing. Okay, since steam curing, what we use, it is used for accelerated strength gain, and it requires additional heat to perform hydration. Since steam curing, we increase the temperature of the surrounding, and as we increase the temperature, the kinetics of reaction will increase, and I will have a faster strength gain to happen. And this I can achieve in two manners, either using steam at atmospheric pressure, or using high pressure steam using a autoclave. Okay, so these are different ways. So in atmospheric pressure, you maintain a temperature of 70 to 90 degree 90 degree. Okay, and it is done in four stages. So there will be in temperature cycle, like initial heating period. Okay, there will be a delay period first, then heating period, then will be maximum period, temperature period, and then there will be curing period. So in this way, steam curing is done. And high pressure steam curing can also be performed, where temperature is kept fixed and a pressure of the such range is applied to increase the curing. Now try to answer this question based on compaction and curing, and you can ask your queries anyone if you have any doubts in this section. So this is like mostly the theory part. Like there's not much thing to like discuss in this, but I've tried to discuss different ways in which compaction curing happens, and I've tried to explain them through images so that you can remember them more properly. Okay, just try to answer. These are very simple questions now for you. So, what will be the answer for question number 17? Construction project in a hot and dry region is experiencing rapid moisture loss in a freshly placed concrete. Despite what proper water curing, cracks are appearing at the surface. The construction team is considering various curing techniques. Which of the following method is the most effective? So, what will be the answer for this? Can anyone try? So remember these keywords that are there in the question. It is a hot and a dry region which is experiencing rapid moisture loss. Okay, so the correct answer for this will be D. Why? Because since it is experiencing rapid moisture loss in hot and dry region, any kind of water spraying like spraying or covering with wet cloth or ponding the entire surface, it may not be good enough because water may evaporate at a very fast rate and again my concrete may get exposed. So the best way is to apply a curing compound which will create a film which will prevent any evaporation or anything to happen from the surface, and it will ensure there is proper hydration. Okay, so generally for hot and dry regions we use curing compounds after finishing of concrete surface. Now question number 18, which of the following is not used for compacting concrete in deep foundations? So here this keyword will be deep foundation. Can anyone tell the answer?
Surface vibrators.
Okay, so the correct answer is surface vibrator. Why? Because this vibrator will only work till a shallow depth and it won't be effective for deep foundation. Answer can be this also, rodding and damping, because again it may not be suitable for deep foundation. Okay, for deep foundation we need internal vibrators or external foam vibrators which will be most suitable. Question number 19. A newly cast concrete bridge deck is exposed to direct sunlight and strong wind. Which of the following curing method would be least effective? Okay, we are talking about least effective and direct sunlight and strong wind exposure.
Air curing with occasional water sprinkling.
Anyone else can answer? Any other option if you think? Okay, since they are talking about least effective method, it will be air curing with occasional water sprinkling. Why? Because in direct sunlight and strong wind, occasional sprinkling does not provide continuous moisture. Okay, and since if there is no continuous moisture, there can be evaporation and shrinkage crack. Okay, so that's why it is the least effective. The most effective among this will be wet covering or curing compound application. Okay, so this may be the most effective method among these choices, but the least effective will be air curing. Now try to answer this case study kind of question. Okay, so there's a contractor who has some site observation and he wants to report what is the likely reason for strength reduction. Okay, so just read the question once and try to answer. So a contractor observes that despite proper curing for 7 days, concrete cylinders tested at the lab shows a lower strength than expected. And the site conditions were this. Ambient temperature was 10 degree, humidity was 50% and sprinkler system of curing was used. Now, what is the most likely reason for strength reduction? I won't say strength reduction, but not meeting the expected strength level. What is the most likely reason for not meeting the expectation?
Low curing temperature slowing hydration.
Anyone else thinks anything, any other answer? Okay, so the correct answer is B here. Why? Because at 10-degree temperature, the hydration will proceed slowly. Okay, the hydration process will slow down and it will delay the strength gain. Okay, and that's why they were not experiencing enough strength gain after 7 days. Okay, so that can be the most likely reason for strength reduction. Even after proper curing, it can happen. Now, this last question: what is the most suitable curing technique for underwater concreting?
Sir. Steam curing.
So, the correct answer is D here. Since it is underwater concreting, my concrete is already submerged in water, so I don't need any additional curing. Okay, so curing is actually happening on my concrete. I don't need to provide any additional curing. Okay, okay, so this was all for today's session. So we first discussed with the ready mix concrete, its benefits and detrimental effect. We discussed about post mixing operations, starting from transportation, pumping, compaction, and ending with curing. And we also discussed workability of concrete in fresh state, compactability, and other factors which define workability. Stability, compactability, and one more factor was there. Okay, three factors we discussed. And we also discussed about underwater concreting. Okay, thank you.